Salam sejahtera and a very good day. I be to my viewer. My name is Daniel, and along with my colleague, Ms. K.RAVEENDRAN, today we are proposing our project to MTE SDG IIAE 2024 submission for our project titled Energy Efficient Green Biohydrogen Production from Malaysia Palm Oil Biomass. The main motivation for this project is on energy transition, especially on the idea of hydrogen being a sustainable energy of the future. The main bottleneck of this technology is on the source of our hydrogen, in which our particular question is how clean is our hydrogen source exactly? Now, despite the growing enthusiasm, the world hydrogen production is still from non-renewable sources, which natural gas accounts for about 70% of the world hydrogen production, in which a process called Steam Methane Reforming or SMR. SMR is a very mature technology and has very advantageous economical and energy efficient advantages compared to green hydrogen production alternatives, such as electrolysis, which requires almost twice as much as the energy needed compared to SMR. This leads to the main problem statement that we want to tackle here, in which we need to make more green hydrogen, and not only green hydrogen, a green hydrogen that is also energy efficient. This leads to our novel idea, in which this project proposes a thermal optimized green biohydrogen production using biogas, sourced from palm oil biomass, especially in this particular project from Malaysia, as a feedstock for the SMR to replace the dependency on natural gas. This is our proposed process flow concept, the novelty that we want to show over here. The biogas can be obtained from the biomass from the pome, which is from palm oil meal effluent. The biogas can be separated into two different parallel channel. One to produce energy through CCGT, gas turbine, and HRSG, and the other channel to be channeled to SMR for hydrogen production over here. SMR is a very high energy and heat intensive processes, in which we are proposing to use a thermal optimized process from the excess heat from gas turbine to support the SMR processes, in which K.RAVEENDRAN can reduce the energy needed to produce the hydrogen over here. This optimized process for our flow sheet as simulated using our Aspen HYSYS. It has been simulated until we reach convergence. This is our result efficiency analysis results. We compared three different cases, one from research, second from base, and lastly our novel optimized thermal optimized proposal. It was found that from research, in order to produce 1 kilogram of hydrogen, it requires 22.25 kilowatt hour energy. And from our optimized plant, it can reduce to only 13 kilowatt hour of energy, a boost of 70% of efficiency compared to research. And for power generation point of view, 1 kilogram of biogas can produce 1.48 kilowatt hour of energy in our optimized plant, because we are proposing CCGT power plant. It can do up to 1.68 kilowatt hour energy, and about 14% increase in optimized energy efficiency. The optimized plant offers significant increase in hydrogen production. This correlates to the optimized plant requires less energy to heat the steam and biogas for the feedstock for the SMR, as it utilizes the waste heat from the GT. And the power generation, the proposed power plant gives an acceptable efficiency when compared to research value. Let's discuss on our impact, our project impact. We have underlined three main impact that relates to the SDG 7 and 13. One is it can promote a new commodity from the palm oil mill biomass plant. Our current practice is the biomass plant can produce energy, which is from a boiler. But now we are proposing that it can produce green hydrogen, biohydrogen production as well. Secondly, it improves the efficiency of the green biohydrogen power plant. As you can see, it can go up to 70% more efficient, as it utilizes the exhaust heat from the gas turbine to support the operation of the SMR for the general optimization of the plant. And thirdly, to reduce the emission of the greenhouse gases. It can reduce the greenhouse gases, especially methane and carbon dioxide, from the palm oil waste biomass. And lastly, some recognition of our project. The project has won several awards from Uni10 with recognition from IEEE Malaysia. And our plan is to do a more fiscal and economic viability study, in which we focus on the CAPEX, APEX, capex, opex, and maintenance to ascertain the commercial viability of this proposed system. With that, I thank you.